All right, for question 38, it says the revenue function is r of x equals 100x minus 0.01 x squared. So that's my revenue function. Let me get my ink back going here. Okay, so that's my revenue function. And here's your cost function. So it says if you are trying to operate where marginal revenue, the second you see a marginal, you should say that's my first derivative, where it equals marginal cost, they want to know what you're going to produce, and that's your x. So the first thing I'm going to do is find marginal revenue. That's going to be 100 minus 0.02 x. Okay, I just took the derivative. Let's get marginal cost now. That's going to just be 50. So if you're going to operate where marginal revenue, which is 100 minus 0.02x, equals marginal cost, which is 50, you have a one-step, well, I guess a two-step problem. So the first thing I'm going to do is subtract 50 from both sides and then bring the 0.02 over. So 100 minus 50 is going to give me 50, and I'm trusting that you can do this kind of work. 50 is going to equal 0.02x. Divide by 0.02 to get x by itself. And you get an x value equal to 2,500. That's your production level. So look what I did. I needed to recognize that this is marginal revenue and this is marginal cost. Set them equal, solve for x. This is your production level. I don't really have any kind of units, so I'm just going to call it units. I don't know what I'm producing, but that's how much I want to produce of it if I want to operate where marginal revenue equals marginal cost. Okay, let's move on to question number 39. All right, question 39 says find the minimum cost if this function is my cost function. And then I have to verify I found the minimum by both the first and the second derivative tests. So first thing I'm going to do to find the minimum, I'm going to find the first derivative and set it equal to 0 and solve. Because where the slope is 0, that could potentially be my minimum. So c prime is going to equal 3x squared minus 10x minus 13. Okay, set that equal to 0. That's going to be a hard factoring problem. I'm going to let you figure out how to do the hard factoring just to minimize the time we're spending on the video. But you should be able to factor this, and when I factor it, I get this for my factors. Set my factors equal to 0, I get two x values. My first x value is x equals -1, and my second x value is x equals positive 13 over 3, which is roughly what did I think? 4.3. Okay, so this is about 4.3 bar notation. All right, so the easiest thing to do to evaluate this, because now I have my x values, but I don't know if they're minimums or not. So I'm going to put it on a number line. And I'm going to evaluate my slope, so my c prime of x, on that number line. So here are my critical values. That's the numbers we just found. So I have a -1, and I also have a 13/3, which we said is about 4.3. So I'm going to test a value to the left of -1, because I want to see what that looks like in terms of the slope value. So take your first derivative, which is right here, and I'm going to pick a value to the left of -1. How about -2? Okay, so evaluate, figure out what is going to be the value of the slope if my x value is -2. So -2, I'm plugging it into the factors now. -2 plus 1 gives me a negative. okay? Plug in negative 2 to 3x minus 13. So that's negative 6 minus 13. That's another negative. A negative times a negative is a positive. So when I plug in, I would get a positive value right there for all the numbers to the left or below negative 1. Okay, the easiest critical value to test in between negative 1 and 13/4 is 0. So take the 0 and plug it in. So I'm going to find C prime of 0. And if I plug it in the first factor, which is x plus 1, I get a positive. If I plug it in the second factor, which is 3x minus 13, I get a negative. And a positive times a negative will get me a negative. Now let's check to the left of 13/4. So I'm going to plug in a 5 because remember 13/4 is 4.3. So plugging in a 5 in the first factor, x plus 1, 5 plus 1 is 6. That's a positive. Plug in a 5 into 3x minus 13. That's 15x minus 13. That's a positive. A positive times a positive gives me a positive. All right, what do these signs mean? So remember, we're talking about slope. So if slope is positive and then turns negative, I have a max. So at negative 1, by the first derivative test, I have a max. If instead the slope is negative and turns positive, I have a min. So right now, I'm looking at a min where x is 13/4. Okay, so this is going to be a min. So that is by the first derivative test. I know that that value is a min. They also are asking me to verify it by the second derivative test. So let's get rid of some of this material over here, and we'll do the second derivative test. Okay, so I'm just going to cut this out. And let me go back for 1 second. Okay, I cleaned this up a little bit. So this, we'll put a red box around it. This was my justification for my first derivative test. I would clearly write a statement then and explain how if I go from a slope that's positive to a slope that's negative, I am identifying a max, as opposed to going from a slope that's negative to positive, which identifies a min. So that's all first derivative. Now let's do a second derivative test. So in order to do a second derivative test, I need a second derivative. So let's get the second derivative, which is going to be 6x minus 10. So to do a second derivative test, what you're going to do, you're going to figure out what is the second derivative evaluated at negative 1. And when you plug in a negative 1, you get a negative 6 minus 10, so that is going more negative, so your value will be negative. Let's instead plug in 13/3. Let me just clean that up. Okay, so if I plug in 13/3, what's going to happen? Well, 13/3, let's see, that's about 4. That's going to end up being a positive number, so that's positive. Okay, what do I know about second derivative tests? If my second derivative is negative, my function is concave down, which is a max. If my second derivative is positive, my function is concave up, which is a min. So by both the first derivative test, which tests slope on either side of the critical value, I get a max at negative 1, and the min, which is what I'm looking for, at 13/3. The second derivative test checks concavity. If a function is concave down at a critical value, that means I have a max. If a function is concave up at the critical value, that means I have a min. So my second derivative test verified what my first derivative test found. And that's how you set these tests up. So let's move on to question number 40. Okay, to start question 40, I'm going to call your attention to the equation. And this is the equation that they're speaking about, but you do not have to work with that equation because it says the graph of this function and its derivative are sketched below. Using the graphs and your knowledge of calculus, provide approximate answers to the following questions. Okay, so since we're not going to have to look at this again, I'm going to move to the next slide where I can show you the graphs that we're going to be referencing. Okay, so these are what the graphs look like. And the graph on the left is the original function that I spoke of a second ago, and the graph at the right is the first derivative. So let's read the questions and see if we can get our best answers. The graph of this function and its derivative is sketched below. Using the graphs, we're going to answer these questions. What is the average weekly temperature at week 18? Well, average weekly temperature is what the original function is giving us. So if you go to week 18, which is about, if this is 15, this is about 18, and you go up and you go over, it looks to me like we are at 70. So I would say 70, looks like 70 degrees is the best answer right there. Okay, next question. At week 20, how fast is the temperature changing? That is referring to the slope, or the first derivative. So find week 20, and I'm going to find week 20 here, go up and go over, and it looks like 1.5, positive 1.5 degrees per week, because it's a derivative, it's a slope, is the best answer there. Okay, next question. Let me just clean this up as I'm looking at it. Okay, next question says, during which weeks is the average weekly temperature 39 degrees? So remember the degrees is on the y-axis, so we're going to go over to the original function because they're asking us for the average weekly temperature. They're not saying anything about things changing, how fast, falling, nothing. It's just average weekly temperature. So find 39 degrees, which is going to be right about here. Right about here, and I'm going to draw over, and I see I hit it in 3 places. So if I draw vertically down, which I guess it's hard to do with this, if I draw vertically down all 3 places, and this is tough with this, so if you do it with a straight edge, you should get the temperature or the weeks of 7, 44, and 58. Those are your best answers or something close to that. Okay, question D. When is the average weekly temperature falling? Okay, falling means it's going to be negative at a rate of 1 degree per week. So when is the weekly temperature falling at 1 degree per week? That means the slope is going to be -1. Here is where -1 is, right here. So draw a cross, and you see a cross is right here. And so go up and figure out what week that is, and it looks to me it's about week 28 or so. So this is week 28. That's my good answer for that. Okay, question E. When is the average weekly temperature greatest? That's the original function. They're asking you where the max is. And so the max is right at this point, right over here. So look down, and it appears to me that we are right about here, if I go straight down, which is going to be week 25. So this answer is 25. Okay, the next one is, when is this temperature the least? Okay, I think it's time to get this cleaned up. and we can look at where it is the least. You should be thinking about this. Which graph am I going to work on? I believe I'm going to work on the original function. So when is it the least? The least is at the lowest point. Here's a low right here. Whoops. Here's a low right here. And it looks like it's just a little bit to the right of 50. So I would say about 52 weeks or so. Okay, this is another minimum over here, but that's negative time, and we're not doing negative time. So your only answer is 52 weeks. Okay, question F. When is the average weekly temperature increasing fastest? Okay, increasing fastest, think about what that means. If it's increasing the fastest, it means that it's the steepest part of my curve. Well, it's hard to tell where that is on the original function, so go for the max of your first derivative. And if you find your max, it looks to me between 10 and 15, so I believe 13 is a good answer. Okay, then when is it decreasing fastest? Okay, another inflection point is what we're looking for. It's decreasing fastest in here. It had been increasing fastest in here. This was the max. This was right here the max on your original function. So this decreasing fastest is going to be the min. So the min looks like it's right about here. And if you read up, it looks like it's about 37. So 37 weeks is the best answer there. So that finishes this question.